Hey folks, welcome to part 2 of lecture 1.3, talking about sig figs. So now we're going to jump right into looking at rules to determine number of significant figures. Okay, so here is a summary of the rules. We're going to walk through these one by one and then take some examples and put it to practice. All right, so the first one is uh, all non-zero numbers are significant. So if you go back to the example of 10.4 at the beginning, the 1 and the 4 absolutely are significant. Okay, which means like you wouldn't say them if you didn't know them. All zeros in between another numbers are significant, like the 0 here. Okay, these numbers are all sig figs. Trailing zeros are significant if after the decimal. That's the example that I gave before, like this. If I add a 0 here, then that 0 matters, right? It's contributing to my certainty, and that would be a significant figure if it's after the decimal. Another example would be a 0 before the decimal, which is really not doing any work at all, right? That 0 would not be significant. So I guess I'm getting ahead of myself here. That's leading zeros are not significant. Another example of leading zeros would be like this. So these zeros here are what you would call placeholders, right? They're just telling you where that 4 is, but they're not actually significant. And trailing zeros are not significant if after, or if there is no decimal. This one's a little bit weird and confusing at first, but this means that a number like 500, these zeros are not significant. We don't know whether it's 500 plus or minus 100 or what. 520 would have two significant figures, and the 0 would not be significant. Okay, these are the general rules about sig figs. Here are some examples of numbers. Then I want you to answer how many sig figs do these numbers have? So pause it and take all the time you need, and then you shall return. Okay, welcome back. So the first one, 3.45. Well, that has 3 sig figs, right? And this, I guess I should say, this will matter when we start doing calculations. The number of significant figures in the numbers that you use in your calculations will determine your certainty and precision of your answer at the end. Okay. Next, 3.05 has also 3. Okay, 0.400. This first 0 is not significant. It's a leading 0. These two zeros are trailing zeros after the decimal, so they count. So this also has 3. Same argument in the next one, 4.0. The 0 here matters, so that has 2. 6,000 has just 1, right? The zeros here, we don't know if this is to the nearest thousandth or 1. We don't even know. If you wanted to show the dot means that they're significant. Next, 0.00040. These first ones are just placeholders, so it says 2 sig figs. Okay, scientific notation is really useful, and I'll show you why. So this number right here, 2.30 times 10 to the 4, 2 3, and 0, all significant. This is a trailing 0 after the decimal, so it has 3. However, if you write this number out, it's 2,300, and this number would only have 2 sig figs. So if you are you have one of these situations where you actually know it, like this one to the nearest tenth, but this way of expressing it has no way to show you that scientific notation is useful. Okay, the last one. 4 people. It has an infinite number of significant figures because it's an exact number. Okay, I know I went through that fast, but hopefully you took the time prior to that to think about it, and you can always go back and think more about it now that you have control over the timing of this lecture. Okay, so here was a bunch of numbers, and I asked how many sig figs. Now I'm going to tell you, find the one that has 4 significant figures. Okay, go ahead and pause it. And welcome back. Okay, everybody got it? You got B, right? Let's see why. A has, no, how many? A has 3. C has just 2. D has 3. And E has 5. Remember, these zeros don't count. These zeros don't count. These zeros don't count. But in this one, in B, this 0 does count. Because it's telling us that we know it. It's giving us more information, right? We know this number to the nearest 10th place. 235.0 is different than 235. All right, I think this is going to be short, so let's power through. And we'll do significant figures in calculation. So we'll finally apply it, like why this matters here. So one of the set of rules is multiplying and dividing. Okay, if you're multiplying and dividing numbers, then the calculated answer cannot have more significant figures than the measurement with the fewest number of significant figures. Essentially, if you, let's say you have 2 numbers that you've measured. One you have really a lot of certainty about, a lot of sig figs, and the other one was really rough and coarse, and you don't have very much certainty in it. When you multiply by these 2 numbers, you can't all of a sudden produce a precise number out of a junky number that went in, right? It's limited by the measurement with the fewest number of significant figures. Here's an example. So you have 4.559 times 5.6, and you plug it into your calculator, and it gives you 25.5304 because your calculator doesn't know anything about sig figs. It just gives you the math. So you have to know that this first number has 4 sig figs, and the second number has 2 sig figs, and so your final answer can only have 2 significant figures. And so what do? You have to round it. Okay, and remember your rounding rules. If it's if it's 5, you round up. If it's less than 5, you round down. So 25.5304 rounded to 2 numbers would give us 26. So 26, so 2 sig figs. Be very careful with this. Okay. From now on, any calculation that we do, we're going to consider significant figures. Okay, so the same rule applies for division. And here's another example to work through. In nutrition, the energy available from a food is often measured in calories. In one study, researchers find a 57-gram candy bar contains 283 calories. How many calories are present in each gram of this candy bar? And then, of course, report your answer with the correct number of sig figs, or significant digits. So we want calories per gram, right? We see that from the question here. How many calories are present in each gram of this candy bar? What that means is we want to take 283 calories divided by 57 grams. And that would give us calories per gram. Now when you plug this into your calculator, you will get something like 4.96491221. Great. Okay, now you know that we don't actually know the number that well, right? That's just what the calculator says. We have to think for ourselves and look at sig figs. So this number has 3, this number has 2, so our final answer must only have 2. And so 4.96 would round to 5.0 calories per gram. Here's a question. How many significant figures does the correct answer to this problem have? We don't even care what the answer is, just how many sig figs. So all you need to know is how many does this number have, and how many does this number have, and which number is the fewest. So here we have 3, here we have 4, and so the answer, whatever it is, would only be 3. It is, by the way, 717.885 on my calculator. So to 3 would be 718. So notice, even though these have decimal places, we don't care. It's just the total number of significant figures, which is different than the rule for plus minus. So when you're adding or subtracting, the final calculated answer cannot have more places past the decimal than the measurement with the fewest places past the decimal. Okay, so here it's helpful to line up on the decimal, and you can see the places. So the first number here, 4.559, has 4 sig figs total, but it only has 3 decimal places. And 5.6 has 2 total, but only 1 place after the decimal. And so when we add them up, we get 10.159, but we want only 1 place after the decimal. So 10.159 would round to 10.2. So the final answer, 10.2, how many sig figs is that? It's 3. So even though this one had 4, this one had 2, our final answer has 3. Well, that's because it's dependent on after the decimal, not the total number. So you can end up with situations like this where it's different. Here's another practice problem. To what place is the correct answer in this problem rounded? You don't have to, but it kind of helps to line it up on the decimal. And we can see that we're down to 2 places after the decimal, which would be hundredths place. And it would actually have a value of 15.567. So rounded, that would be 15.57. And the final thing I think we have here today is combining addition and subtraction and multiplication and division in a calculation. So here we just need to follow the sig fig calculation rules along the way, keeping track of significant figures, But here's the key. Don't round until the end. Okay? So here, maybe it's supposed to be parentheses here. We should do the addition and the subtraction first, and then we will divide. So on the numerator, 34.123 plus 9.30 would be 43.423. Now notice I made the 3 little. This answer, if we were done right now, would only have 2 places after the decimal. But I don't want to round it until the end. So I'm going to keep that 3 there, but I want to remind myself that it's not technically significant, but I'm going to keep it around. So I'm going to make it small. Same thing on the bottom here. The subtraction gives me 93.594 with a little 4, because I have 4 places after the decimal here, 3 here, so only keeping 3 if I was done, but I'm going to keep the extra one around just so I don't round until the end. Now I can do the division, and I can see that this number has 4 sig figs. This one has 5. So my final answer will have 4. But using the whole number, or the complete number, I get 0.4639. And I'm just going to keep going. 463948697 is what my calculator says. Okay, but I only want 4 sig figs. So I have to round 3, round it. And here it's 48, we'll round down. And there's my final answer. Okay. So don't round until the end is the key, but keep track along the way of how many sig figs each number has. Okay, that wraps up sig figs in this section, but this is a really important topic, and I will keep reminding you about significant figures throughout the entire semester. So thanks for watching. Go do the post-lecture questions and let me know how it's going. See you soon. Bye.